Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and Joel, his brother. Seth's up there in Albany, north of New York City. I'm in the Bronx. We're outside. Very nice today. We are all hopefully here to help you approach SAT math questions and approach studying for the Math SAT. Khan Academy partners with the College Board, and they post 2016 SATs, have about 40 topics. Khan Academy gives you 20 questions per topic. We are at the highest of the 4 levels, and this is question 1. And we plan over the next few months, years perhaps, we plan to go through every single one of the at least upper level questions, which should give us about 200 questions to go over. Okay, here we go. Please do the question, read it, and then pause the video, and we will come back. And usually our policy, especially mine, although Seth is reading it, he shouldn't be, is I try to do the questions cold. Okay. Scatterplot is here. Depicts the number of women in the United States Congress. F. Oh, F for female. Got it. From 1970 to 2009. Okay. If X represents the number of years since 1970, okay, it says it right there, which of the following is the best X? But X, oh, they're so nice. They gave us an exponential model. They told us it's exponential, not linear. So my first thing about this is let's see how different all these numbers are, and if they all represent highly different curves, then it'll be fairly easy to tell the answer. If one of them represents a curve that's fairly similar to the other, then we have a problem. You could also use a calculate a question, but really, it's the value. The initial value here is 10, or a little bit above 10.
Is
right?
it? No.
Wait,
the initial value was 0.
No, on the graph. Oh, the Scatterplot graph. The initial value. Oh, well, no. X is 0. If X is 0, that makes this a 1, doesn't it?
That's right.
Yeah.
So when X is 0, is 0, the value of F is approximately 10.
Right. So anything.
And so it's either B or C, because 12 and 59, 590 thousandths is approximately 10.
So now
second step is that it goes up.
Right.
Now in B, the base is less than 1. Exactly. If you take a number that's less than 1 and multiply it by itself, you get an even smaller number.
Absolutely.
And so B gives us a function whose curve goes down. C, the base is greater than 1, and when you multiply a number greater than 1 by itself, you get an even bigger number. So it goes up. So it would be C.
That's right. So we don't really even care that much about the exact numbers. We can just tell just by the trend and what it does, only because the answers are very different. The answers represent highly different types of functions. Highly different.
No, they're all exponential.
Yeah, they're all, no, but the behavior, highly different behavior.
Now, the numerical behavior.
Yes, the numerical behavior.
Not the qualitative behavior. The only difference in qualitative behavior is between this one where the base is less than 1 and the others in which the base is greater than 1.
Right. So
now this one, the base is huge. It's 12.
So you need a reasonable starting value.
Yeah.
And the correct base.
Yeah.
Right? And that's the two things you need to. Sorry for my poor handwriting. Sorry. Reasonable starting value. Wait, can't even read that. Oh, God. But just, I'm reading it out, right? Reasonable starting value. Well, that's complete. That is completely unreadable, right?
Yes, completely
That is
unreadable.
completely unreadable. So why don't we use a high-tech thing here? Why don't I type it? You
Yeah.
need a reasonable starting value and a reasonable base, right? To
Mm.
model the scatterplot, to have the same behavior as the scatterplot. How about to have the same behavior as the scatterplot?
Yeah.
Okay, that does it. Anything else to say
Uh,
today? What is a
no.
scatterplot? A scatterplot is just a bunch of observations that someone made, and they just want to they want to see what the relationship between two things are. What's that fancy word? Bivariate or something?
Yeah.
Yeah. Two numbers, you want to see what the relationship is between them. If there is a relationship.
Mm.
Yeah, you do this because you want to test, is there a relationship between the number of years and the number of women in Congress? So that does seem to go up every year, which exponentially during that period. So
Except that after 25 years, this looks like exponential growth.
right.
This is what it looks like. But after 25 years, gets this stuff.
Yeah, it's becoming more
It
linear.
falls off.
Right. Yeah. Yeah, I mean, it's still going up. It looks more linear during that period.
But what happens is this is characteristic of saturation.
Hmm.
You cannot have, it cannot go up exponentially forever, because otherwise we would have the model would give us more women than there are seats in Congress.
That's right. Right. Exactly. Yep. Yeah, that's why it's
Yeah.
only from 2
Yeah.
years. Yeah.
Yeah. Yeah.
Okay, it's actually 39, not 25. Oh, yes, yeah, you want 25. That's what you meant. That's what you meant. You meant 25.
Yeah.
Oh, so annoying when the computer does what it's supposed to do. Okay, so let's just see how they do it. In order to get to this question, which is the 16th question out of the 20th, you have to go through all 15 questions first. So you should definitely do that. Okay, so let's see how they do it.
But pick the answer and let's see.
Yep, let's
their
see how they do it.
explanation.
And let's clear the drawings so everyone can read everything. And then we go here. Okay. They give the reason why those are wrong. Okay, let's see why you do it right. Okay, the graph of any function is written in the form a b to the x, y-intercept of a, and a rate of exponential growth determined by b. Let's look closely at the scatterplot to determine what the key features that the correct function should have. Wow, look at that. So they're doing it the same way we did it. Yeah, they did it the same way. Yeah, they basically say that the r to the a and b to the x, b has to be greater than 1. When b is less than 1, it depicts an exponential decay. Wow, so yeah, we did it. There's really only one practical way to do this problem, and we both approached it the same way. We did it the same way as they did. So what do you think? Oh, look, and there's and there's actually the curve. Look at that.
Oh, wow.
Yeah.
Huh. That's interesting. Okay. So it doesn't shoot up. That's cool. Yeah. So, that's informative. Yeah. I was wrong about my guess. It's broad. It's a flatter curve in the scale that they showed, and there's a lot of variation around it, but that's how. So the exponential growth is slower than what's indicated by the growth here. But the true data shows a smaller amount of growth over here, and then a jump.
Yeah.
Which again, it's level, and then there's a jump it's level, and there's a jump and then a jump, and so that is the exponential fit.
Yeah.
Okay.
Yeah.
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 So in the scatterplot data, there is no sign, no there's no convincing there's no really convincing sign that the true data has begun to level off.
Yeah.
So let's see, 1970 plus 40 is up to 2010.
Yeah.
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 But I wonder now it's now we're 13 years past 2010.
Right.
I wonder what the picture is now.
And this is Congress. This includes first of all, we don't know, this may be completely made up. Right? We don't just because Khan can be published, it doesn't mean it's true. It probably is, though. I mean, why would they lie, right? Why would they use a thing that isn't true? But this is what Congress includes, the House and the Senate.
Yes.
Yeah. Okay. So, I guess that does it, right? Please email us at satmathquestionoftheday@gmail.com with your SAT math questions, or please leave a comment on our YouTube videos. Just constructive comments are always welcome, but any comment is also welcome, because every comment we consider as constructive. Okay, everyone, have a great day, and hope to see you tomorrow. Bye-bye.
Yeah, done.